Why did Yves Chauvin, France, Robert H. Grubbs, United States, and Richard R. Schrock, United States, win the Nobel Prize for Chemistry?
For the development of the metathesis method in organic synthesis. Chauvin, Grubbs, and Schrock shared the prize for their work on a metal-catalyzed reaction that exchanges, metathesis, carbon-carbon double bonds. Many of the double bonds that react with these catalysts are very strong. So a reaction that breaks both bonds of a double bond is impressive indeed. Chauvin was the first to propose a detailed mechanism for this catalyzed reaction. Grubbs and Schrock independently developed extremely active catalysts for this reaction using primarily molybdenum and ruthenium metal centers, respectively.
How do solar cells work?
The sun gives off 1000 watts of energy per square meter of the Earth's surface, which, if we could harness all of it, is more than enough to fulfill all of the world's current electricity needs. It's not easy to do this, however, which is why we still rely primarily on other energy sources. A solar cell, or photovoltaic cell, harnesses energy from photons of sunlight by having them excite electrons in a material. An electric field is established within the solar cell using a process called doping. And this makes it so that the excited electrons can only flow in one direction. Thus, when sunlight strikes the solar cell, a current flows. And this is the basic principle on which solar cells operate to capture energy. The harnessed energy can either be used immediately or it can be stored for later use. Designing more efficient solar cells is a very active area of research. And you can expect their efficiency to continue to increase in coming years.
How is radiation used in medicine?
We should begin by pointing out the distinction between radiation used in nuclear medicine / radiopharmaceuticals, more akin to the other topics of this chapter, and electromagnetic radiation, light of different wavelengths. Nuclear medicine is the branch of medicine most closely tied to the concepts of nuclear chemistry discussed in this chapter. Diagnosis via nuclear medicine typically involves the injection of a radiopharmaceutical into the body. And the radiation released by this drug can then be monitored to gain information about organ function, blood flow, the location of a tumor, or to locate a fractured bone. In some cases, the use of nuclear medicine can allow for earlier diagnosis than with other imaging techniques. In terms of using electromagnetic radiation for medical applications, perhaps one of the first treatments that come to mind is radiation therapy, which is used to fight against a broad range of cancers. This involves using focused electromagnetic radiation to damage the DNA in the tissue of a tumor while hopefully not causing too much damage to the surrounding healthy tissue. The goal is to damage the DNA of cancerous cells so that they are unable to reproduce, hopefully killing the tumor with time. Beams of radiation are focused onto the tumor from different angles to minimize the effect on any one area of healthy tissue. Rays and CT scans are two commonly used, non-invasive medical techniques that make use of electromagnetic radiation to take pictures of what's going on inside the human body. It should be noted that prolonged exposure to the X-rays used in these procedures can be harmful and are capable of causing cancer themselves over long periods of time.
How do living things store fat?
Fat is stored in a type of tissue called adipose tissue. This is made up of cells called adipocytes that store lipid molecules to be used for longer-term energy storage.
What is an unimolecular reaction?
A reaction that takes place involving only a single reactant molecule. There can be one or more product molecules formed.
What is a galaxy?
A galaxy is a huge system consisting of stars, planets, gas, dust, and lots of other interstellar media. The galaxy we live in is called the Milky Way. Galaxies have a lot of stars, smallest have roughly 10 million, while the largest have 100 trillion. All of the stuff in a galaxy orbits around the center of mass of that galaxy.
What is a substituent?
A substituent is an atom, or group of atoms, attached to a specific position in a molecule. For example, in the molecule 3-bromopentane, see drawing below. We could refer to the bromine as a substituent on the third carbon atom.
Why did Sir Robert Robinson, United Kingdom, win the Nobel Prize for Chemistry?
For his investigations on plant products of biological importance, especially the alkaloids. Robinson made significant advances in medicinal chemistry, both in synthesis and in gaining a better understanding of the mechanisms by which drugs work. His Nobel Prize was awarded for his work with alkaloids in particular, including quinine, cocaine, and atropine. Robinson studied and helped to understand how these types of molecules have their effects on the human body and mind.
How can I make a chicken bone flexible?
Chemistry principles encountered in this experiment: solubility in weak acids. Materials you'll need: a jar vinegar, enough to fill the jar, a chicken bone. One from a drumstick works best. The procedure: obtain a chicken bone, and clean it well. Rinse it with water and remove any remaining skin or meat from the bone. Before you soften the bone, try bending it to make sure it is rigid. Don't break it, but test that it is indeed hard. Fill up the jar with vinegar, and drop your clean bone inside. Cover the jar, just so that your whole house doesn't start smelling like vinegar. And let it sit for about 3 days. Recall that vinegar is a dilute aqueous solution of acetic acid, which is a weak acid. Over a few days, the acetic acid helps to dissolve the calcium in the chicken bone. Since the calcium plays a key role in keeping bones hard, the bone will soften once the calcium is dissolved. Remove the bone, rinse it off with water, and now try bending it again. It should be noticeably more flexible than before. Now you can see that without enough calcium, your bones will not stay strong. This might also provide a good indication of why it's a good idea to brush your teeth. If you leave behind any foods capable of dissolving calcium still on your teeth, your teeth may lose some of their calcium and begin to become weak.
Why did Rudolph A. Marcus, United States, win the Nobel Prize for Chemistry?
For his contributions to the theory of electron transfer reactions in chemical systems. Marcus received the prize for his work studying electron transfer reactions and developing the theory surrounding this elementary chemical process. The transfer of an electron between two molecules is a ubiquitous process in chemistry, and it is important to a wide range of chemical phenomenon, ranging from the conduction properties of materials to chemical synthesis, to the capture of light by plants for the purpose of harvesting energy. Marcus completed much of the work surrounding the theory of electron transfer in the 1950s and 1960s. And he was able to explain the greatly varying rates of electron transfer observed in different chemical systems. Some aspects of his theories were difficult to confirm experimentally, and were not proven until the 1980s, which contributed to why it took so long for him to receive the Nobel Prize for his work.
What is kinetic energy?
Kinetic energy is the type of energy associated with the movement of an object. Faster moving objects have more kinetic energy, and the kinetic energy of an object is related to its mass, m, and velocity, v, by the equation, E equals 1/2 mv2. This tells us that, for example, if we have two objects of equal mass and one is moving twice as fast as the other. The faster moving object will have 4 times the energy of the slower object. In this illustration, a horse pulls a pendulum into a position where it is about to be released to swing freely. Before it is released, the weight at the end of the pendulum has potential energy A, and when the pendulum is in full swing, it has kinetic energy B.
Why did Derek H. R. Barton, United Kingdom, and Odd Hassel, Norway, win the Nobel Prize for Chemistry?
For their contributions to the development of the concept of conformation and its application in chemistry. Barton and Hassel earned the prize for their work surrounding the conformational analysis of molecules. While we draw a molecule on paper in a specific orientation and conformation, there are, in truth, typically many accessible conformations to a given molecule. This is especially true for floppy molecules. And these are where conformational analysis can be particularly insightful and important. Their work drew attention to the importance of rotations and other conformational changes in chemistry, particularly with regard to organic molecules. They showed that reactivity can actually be significantly influenced by the conformation of a molecule, and that conformational changes may be necessary to promote reactivity or allow for a reaction to take place. Why did Louis F.
How can I make glue from milk?
Chemistry principles encountered in this experiment: solubility, precipitation, filtration. Materials you'll need: hot water, from the tap, is fine, room temperature water 1 tablespoon. Of vinegar 1/2 teaspoon. Baking soda. Coffee filter cup, spoon, small bowl, tablespoons. Powdered milk. The procedure: dissolve 2 tablespoons of powdered milk in 1/4 cup of hot tap water. Mix in 1 tablespoon of vinegar and stir the solution well. Recall that household vinegar is a dilute aqueous solution of acetic acid. At this point the milk should begin to form little blobs of insoluble material, curd. These are a substance called casein, which are a class of proteins found in milk. Proteins are typically soluble in water and aqueous environments, but the acetic acid from the vinegar causes the casein to no longer be soluble in this solution. Position a coffee filter on top of a cup and pour the solution through the filter to collect the curd. To further dry the curd, try to use the filter to squeeze out any remaining liquid. Dispose of the liquid in the cup, dry the inside of the cup, and then transfer the curd from the filter into the now dry cup. Break the curd into smaller chunks using a spoon. This will help it to mix more readily with the ingredients you will add next. Add 1 teaspoon of hot water, and 1/4 of a teaspoon of baking soda to the cup containing the chopped up curd. the mixture may foam a little from the reaction of the baking soda with the remaining vinegar, producing carbon dioxide gas. Stir this mixture, which should eventually become smooth and liquid-like. You may need to add a little more water or baking soda to reach a smooth, even consistency. Now you have your glue. You can use it just like you would any other glue, though you should test it out first to make sure it's working well before you use it for that science fair project you're finishing up.
Why did Paul D. Boyer, United States, and John E. Walker, United Kingdom, win the Nobel Prize for Chemistry?
For their elucidation of the enzymatic mechanism underlying the synthesis of adenosine triphosphate, ATP, and Jens C. Skou, Denmark, for the first discovery of an ion-transporting enzyme, Na+, K+AT-PASE. Boyer and Walker shared half of this prize for their work to understand how ATP synthase, an enzyme, catalyzes the formation of ATP. This information bears a crucial relationship to understanding how energy is stored, transferred, and used in cells. Skou received the other half of the prize for his work to discover the first ion-transporting enzyme, which is responsible for keeping the balance of sodium and potassium concentrations in cells.
Why did Peter Ager, United States, win the Nobel Prize for Chemistry?
For discoveries concerning channels in cell membranes for the discovery of water channels and Roderick MacKinnon, United States. For discoveries concerning channels in cell membranes for structural and mechanistic studies of ion channels. Ager received half of this prize for isolating a membrane protein that serves as a water channel in cells. For roughly 200 years it had been postulated that cells contained channels capable of moving water in and out of cells. But Ager was the first to finally discover a concrete example of a water channel. MacKinnon received the other half of this prize for his work on ion channels, and in particular for his characterization of the spatial structure of a potassium channel. For the first time, this allowed chemists to see how potassium ions flowed in and out of cells.
What is voltage?
The difference in electrical potential between two locations.
What is a polymer?
A chain molecule consisting of a repeating series of a single unit, or possibly multiple repeating units.
Why did Archer John Porter Martin and Richard Lawrence Millington sing? Both United Kingdom, win the Nobel Prize for Chemistry?
For their invention of partition chromatography. Martin and Singh won the prize for their development of the basic principles of chromatography, or the separation of chemical substances based on differences in their chemical properties, often their polarity. In their separation method, a drop of a mixture of compounds is placed on a strip of paper, and a solvent, perhaps water or an alcohol, or a mixture, is drawn up the strip of water, resulting in a separation of the compounds in the mixture. This separation occurs because each component in the mixture interacts differently with the solvent. This method has been expanded upon by a large number of later researchers. And chromatographic methods play a very important role in laboratory chemistry to this day.
What makes metals feel colder than air to the touch?
Metals feel colder than air when you touch them because they are good conductors of heat. The cold metal is able to conduct heat away from your hand through the entire object quickly, making it feel colder than the air around you.
What is a substitution reaction?
A chemical reaction that replaces one substituent with another.
What is a valence band?
Highest energy range in which electrons are normally present at 0 K.
What is the difference between a homogeneous and heterogeneous mixture?
A homogeneous mixture is one that is uniformly mixed and has the same proportions of components throughout the mixture. An example is a transparent solution of sugar dissolved in water. Specifically one in which there is no undissolved sugar floating around. A heterogeneous mixture is one that is not consistent or uniform throughout, such as a glass of sugar water with some chunks of undissolved sugar also floating around.
What are the basic units of length?
Almost every length scale used in science is based on the meter. Chemistry frequently deals with very small lengths, so while you're probably familiar with millimeters, 10 to 3 m, it's hard to have an intuitive sense about just how small a nanometer, 10 to 9 m, is. There's another length scale commonly used when talking about chemical bonds, the angstrom. An angstrom, A, is 1/10 billionth of a meter, 10 to 10 m. The lengths of chemical bonds vary depending on the elements and other factors. but are usually around 1 to 2 A.
What is a substrate?
A molecule that reacts with a reagent, a subjective label as the substrate is also a reagent.
What prevents all of the air from escaping Earth's atmosphere?
Gravity. Every molecule on Earth is pulled toward the planet by gravity, even the very lightest gas molecules. To overcome a planet's gravitational pull, an object, be it a spaceship or a helium atom, must reach at least the escape velocity. Almost all of the molecules in the atmosphere are below this velocity because of the temperature of the planet Earth. Higher temperature equals faster molecules. Almost all? Yes. Earth is very slowly losing its atmospheric gases. The lightest ones go first. About 3 kilograms of H2 escape the gravitational pull of Earth per year. A few particles can escape because kinetic energy of gases is a Boltzmann distribution. And in a Boltzmann distribution there are always very small probabilities of very high values.
How does an air freshener work?
Although there are many different types of air fresheners, most of them are simply perfume dispensers. The perfume is a strong-smelling substance that has a pleasant odor, which masks the stink.
What is a monomer?
If polymer means many parts, a monomer is one part of that whole. A monomer is a molecule that is attached to many copies of itself to make a polymer molecule. Usually these bonds are covalent, but not always.
What makes oil more slippery than water?
The purpose of lubricants, like motor oil, is to reduce the friction between surfaces, so that parts last longer and less energy can be expended in the process of moving them. The key to a good lubricant is that the characteristic length scale for the formation of a thin film of the lubricant must be much smaller than the characteristic length scale of movement in the application. Basically, oils are good lubricants because they can form very thin films that persist even when the parts they serve to lubricate are constantly in motion. This ability to form thin films typically correlates with other properties that are easier to recognize. For example, good lubricants often have a high boiling point, low freezing point, high viscosity, and are stable toward chemical oxidation and changes in temperature.
What is the cerebrum?
The cerebrum is the top part of the brain, and it contains your memories, knowledge, and languages, and it manages your senses as well. The cerebrum is the part of your brain that controls your movements and emotions, and it's where your thoughts take place.
What is graphene?
In one sense, graphene is an unrolled carbon nanotube, or a flattened buckyball. Graphene is a material made of carbon atoms arranged in a hexagonal, honeycomb lattice. It is similar to graphite, except that it is only one sheet of atoms thick. A square meter of graphene weighs less than a milligram. Since its discovery, graphene has garnered significant attention for its electronic, thermal, optical, mechanical, and other properties. There is currently a huge amount of research into the properties and applications of graphene. And one Nobel Prize has been awarded, the 2010 Prize in Physics, for research into its properties.
What is a monomer?
A group of atoms that forms the repeating unit in a polymer.
Do electrons, protons, and neutrons all have the same mass?
Protons, neutrons, and electrons each have different masses. Electrons are, by far, the lightest of the three, with a mass of only about 1/2000 th that of a proton or neutron. Protons and neutrons have similar masses, with that of the neutron being just slightly higher than that of the proton. The masses of the three particles in kilograms are: electron mass 9.1094 x 10 to 31 kilograms, proton mass 1.6726 x 10 to 27 kilograms, neutron mass 1749 x 10 to 27 kilograms.
How does baking soda make my cookies better?
Baking soda is sodium bicarbonate, NaHCO3, and is used in cooking as a leavening agent, as in, it helps things to rise. It does this by releasing carbon dioxide, CO2, which it does in the presence of acids like buttermilk, vinegar, lemon juice, cream of tartar, and so on. The process is much faster at higher temperatures. Once you put your cookies in the oven, the sodium bicarbonate begins to break down, and the carbon dioxide that is released makes tiny little bubbles in the batter. These tiny bubbles get trapped as the cookies bake, making them light and fluffy.
What causes acid rain?
Similar to smog, acid rain is caused by chemical reactions of pollutants. Like sulfur dioxide and nitrogen oxides with oxygen and water in the air. The acidic pollutants formed in these reactions are the cause of acid rain. In addition to environmental pollution due to human activities, volcanic activity can also cause acid rain. Acid rain can be harmful to natural plant life, farm crops, animals, and marine life. It can also be damaging to buildings, depending on what materials were used in their construction.
What is heat treating a material?
Heat treating can be used to achieve different purposes for different materials. But it generally involves heating or cooling a material to a relatively extreme temperature with the goal of changing its properties. Most often, this is done to make a material harder or softer. Heating or cooling the material allows the internal/microscopic structure to change in a way that is preserved when the material returns to ambient temperature.
What is cisplatin, and how does it help to fight cancer?
Cisplatin is a platinum-based compound, see structure below, that reacts with DNA causing it to cross-link, eventually leading to programmed cell death, also known as apoptosis. Cisplatin was the first in a class of platinum-containing anti-cancer drugs. It has been used to fight several types of cancer and is particularly effective against testicular cancer.
What analytical techniques are used in quality control for pharmaceuticals?
Some of the most commonly used analytical techniques in pharmaceutical quality control include infrared spectroscopy, UV/visible spectrophotometry, melting point determination, reactions based on color changes, and various types of chromatography, including thin-layer chromatography, high-performance liquid chromatography, and gas chromatography.
Flory, United States, win the Nobel Prize for Chemistry?
For his fundamental work, both theoretical and experimental, in the physical chemistry of macromolecules. Flory contributed greatly to polymer science by developing metrics for characterizing polymers and for comparing different polymers against one another. This was a task that had often proved difficult due to the different compositions and conformational arrangements found in different polymers. He made great strides toward putting polymer science on a firm theoretical footing, which was lacking when he entered the field.
What are isomers?
Isomers are chemical compounds with the same molecular formula, but which are different in some way. The major types are constitutional isomers, stereoisomers, and enantiomers. The last one is actually a subset of the second to last one, but we'll get there in a minute. Constitutional, or structural, isomers have the same number of atoms, but they are arranged in a different order. For example, 4 carbon atoms and 10 hydrogen atoms can be arranged in 2 different ways.
Why did Otto Paul Hermann Diels and Kurt Alder, both Federal Republic of Germany, win the Nobel Prize for Chemistry?
For their discovery and development of the diene synthesis. Diels and Alder won the prize for the developing chemical reactions that are broadly relevant in organic synthesis. And they even have a reaction named after them called the Diels-Alder reaction. Dienes are complexes containing a pair of conjugated carbon-carbon double bonds, which can react to form a cyclic product in a wide variety of cases. Further research into this class of reactions has found a tremendous number of applications throughout organic chemistry.
What is a Nernst equation?
An equation describing the potential of an electrochemical half cell.
What is miscible?
Liquids that when mixed form a single phase.
Can multiple liquid phases exist for a mixture?
Yes. One familiar example is a mixture of oil and water. The immiscible oil and water phases are 2 different phases of liquid matter.
What is cracking?
Fluid catalytic cracking is the name for the process that converts high-boiling hydrocarbons found in crude oil into lighter hydrocarbons that are more useful as gasoline and other products. These units operate continuously for years at a time, and there are hundreds of them around the world. In addition to the high temperature and heat that these reactors use to break down long hydrocarbons, there are catalysts used to help speed up the process. These catalysts are usually strong acids in the form of zeolites. Specifically fugazit, which is a mixture of silica and alumina.
What is an ohmmeter?
A device used to measure electrical resistance.
What is a superbubble?
A superbubble is a cloud of superheated gas that can be formed when multiple stars that are relatively near each other die out at similar times. This situation can lead to an explosion that spans hundreds of light years in distance. Recall that a light year is the distance that light travels through space in a year. So we are talking about an absolutely huge explosion. The light generated from this explosion is often not in the visible range of the spectrum, so they can't always be seen by the naked eye, not to mention the fact that they are also very, very far away.
How do the boiling point and melting point of a substance change as a solute/impurity is added?
The addition of a solute typically raises the boiling point and lowers the melting point of a substance. These effects are appropriately named boiling point elevation and melting point depression. Boiling points are raised when a nonvolatile solute, like NaCl, is added to a solution because the solute lowers the vapor pressure of the solution. That is a somewhat circular explanation though. It is important to know that this change in boiling point does not depend on what you add to the liquid. So there are no specific interactions going on here, like forming hydrogen bonds, etc. As long as the solute has lower vapor pressure, remember we said it was nonvolatile, so its vapor pressure is essentially zero, this effect will be present. It is perfectly correct to think about it as just lowering the vapor pressure of the mixture. If you add something with very low vapor pressure, the average vapor pressure of whatever liquid you're adding it to will go down. Melting, or freezing, points are usually lowered when a solute is added to a liquid. The best explanation for this effect is based on entropy, see physical and theoretical chemistry. When a molecule of solvent moves from the liquid to the solid phase, freezes, the amount of liquid solvent, i.e., its volume, is reduced. This means the same amount of solute is in a smaller space, which reduces their entropy, or raises their energy. This raising of energy means that you have to take even more energy out of the system for each molecule that joins the solid phase. Less energy means lower temperature, so adding a solute lowers the freezing point. An alternative way to look at this is that any impurity will disrupt the crystal lattice, raising its energy, relative to the liquid phase. This also contributes to lowering the freezing point as solutes are added.
How did chemists figure this out?
They analyzed fart gas by gas chromatography. No, really.
How does fluoride work in toothpaste?
Fluoride, usually in the form of sodium fluoride, NaF, in toothpaste, strengthens the enamel in your teeth. But how does it do that? Let's back up a bit first. Enamel is the outer layer of your teeth. And it's made of a mineral called hydroxyapatite. It's a calcium phosphate structure with one hydroxyl group, Ca5, PO4, 3, O. This mineral dissolves in the presence of acids, which is exactly what bacteria generate when they metabolize sugars in your mouth. This is how cavities form when you drink soda. Fluoride ions help rebuild your tooth's enamel by replacing the hydroxyl group in the apatite mineral. The new mineral, Ca5, PO4, 3F, or fluorapatite, is more stable in the presence of acids, so your teeth are more resistant to decay.
What is the reaction rate?
How fast the reaction takes place. Typically measured in terms of a change in concentration of a chemical species with respect to time.
What is an atomic weight?
The average mass of an atom of a given element.
What is the first law of thermodynamics?
The first law of thermodynamics is a statement of the conservation of energy, which tells us that energy can be transferred from one form to another but never created or destroyed.
What is the octet rule?
A rule for chemical bonding that says atoms prefer to have 8 electrons in their valence shell.
What is a half-life?
The amount of time required to consume half of the initial amount of a reactant.
What is the critical point?
A set of conditions at which no boundary exists between two phases of a substance.
What is an E factor?
The E factor is a metric of how environmentally friendly, or harmful, a chemical process is. Specifically, the E factor is the ratio of kilograms of waste generated per kilogram of product synthesized. Thus, the lower the E factor, the more environmentally benign a process should be. Of course, this is only a single metric, and other factors like the toxicity of the waste produced, should also be taken into account. In pharmaceutical companies, the E factor for the synthesis of drug products is typically in the range of about 25 to 100.
What molecules have chemists detected in interstellar space?
A recent count puts the number of distinct molecules detected in interstellar space at around 150. The list includes small diatomic molecules that are common on Earth, e.g., Co, N2, O2, high-energy diatomic radicals that have exceedingly short lifetimes on Earth, e.g., Ho, HC, and all the way up to organic compounds like acetone, ethylene glycol, and benzene.
Why did Derek H. R. Barton, United Kingdom, and Odd Hassel, Norway, win the Nobel Prize for Chemistry?
For their contributions to the development of the concept of conformation and its application in chemistry. Barton and Hassel earned the prize for their work surrounding the conformational analysis of molecules. While we draw a molecule on paper in a specific orientation and conformation, there are, in truth, typically many accessible conformations to a given molecule. This is especially true for floppy molecules. And these are where conformational analysis can be particularly insightful and important. Their work drew attention to the importance of rotations and other conformational changes in chemistry, particularly with regard to organic molecules. They showed that reactivity can actually be significantly influenced by the conformation of a molecule, and that conformational changes may be necessary to promote reactivity or allow for a reaction to take place. Why did Louis F.
What is the composition of air?
Earth's atmosphere is made up of 78% nitrogen, N2, and 21% oxygen, O2, if you ignore water vapor, which shifts too much to include in averages for the entire planet. The last 1% is made up of mostly argon, Ar, followed by carbon dioxide, CO2, and other trace gases.
What's the difference between saturated and unsaturated fats?
The terms saturated and unsaturated refer directly to the chemistry definition of unsaturation. Unsaturated fats contain carbon-carbon double bonds, units of unsaturation, while saturated fats have only completely saturated carbon chains. Saturated fats, like butter and lard, stack together well in the solid state, so they are generally solid at room temperature. The double bonds in unsaturated fats disrupt this lattice in the solid state. Making these types of fats, like olive oil and vegetable oil, liquid at room temperature.
How are centrifuges used for nuclear power?
Centrifuges are used to enrich the uranium that is used in nuclear power plants. The two main isotopes of uranium are U-235 and U-238. With U-235 being the isotope used to generate nuclear power via fission processes. Unfortunately, over 99% of naturally occurring uranium is U-238. So a lot of effort has to go into enriching the fraction of U-235 present in a sample. Centrifuges are often used to isotopically enrich a sample of uranium in the U-235 isotope. As described in an earlier question, this is accomplished by spinning a centrifuge tube. And in this case the heavier U-238 isotope is weighed down more, allowing a greater fraction of U-235 to be collected, in the gas phase, from the top of the centrifuge. This process can also be facilitated by heating the bottom of the centrifuge tube, which also helps the U-235 to move toward the top of the tube where it is collected. The process is typically repeated many times before the desired fraction of U-235 is reached. Highly enriched uranium often contains 85% uranium-235 though. So clearly people have gotten pretty good at carrying out the isotopic enrichment process.
What is gamma radiation?
While alpha and beta radiation is the loss of some particle from an atom, gamma radiation is the release of electromagnetic radiation, called gamma rays. This energy is typically of a high frequency, greater than 1019 Hz. Which means it's high energy, greater than 100 keV, and can cause significant damage. Gamma radiation can easily penetrate deep into your body. Unlike alpha and beta particles, causing damage to your cells and the DNA inside them. Sometimes this damage is useful, though. And some radiation therapies for cancer treatment make use of gamma radiation to kill the malignant cells.
How can I make a lava lamp at home?
Note, okay, so we'll disclose up front that this experiment won't actually make a lamp. It will make a device with bubbles that rise and fall just like a lava lamp. But you'll need a flashlight or other light source if you want it to be illuminated. Chemistry principles encountered in this experiment: chemical reactions, density, miscibility, gases, materials you'll need. Vegetable oil, 20 ounces. Plastic soda bottle, 20 ounces or 1 liter, water, 1 tablespoon. Alka-Seltzer, R, food coloring. The procedure: begin by filling the plastic bottle almost full with vegetable oil. Add a few drops of food coloring to 1 tablespoon of water. And then add this to the plastic bottle's contents. You'll notice that the oil and water are not miscible, which is what will allow us to make bubbles within the oil. The water sinks to the bottom of the bottle, since it is more dense than the oil. Ground up an Alka-Seltzer, R, tablet and add the pieces/powder to the bottle, and then seal the cap. When the chemicals in the table dissolve and react, carbon dioxide gas bubbles will be formed, see equation below, which will lower the overall density of the water bubbles, allowing them to rise to the top of the bottle. When they reach the top, they will leave the water bubbles and join the small amount of air at the top of the bottle. At this point, the water bubbles will again be denser than the oil, so they will sink back to the bottom of the bottle. This process will repeat until all of the Alka-Seltzer, R, has been reacted. You should see colored bubbles move throughout the bottle, similar to a lava lamp.
How can I grow a large crystal?
Chemistry principles encountered in this experiment, crystallization solubility materials you'll need. Hot water, from the tap is fine, about 2.5 tablespoons of alum. This is typically found with the spices in the grocery store. It is an ingredient used to make pickles crisp. Its chemical formula is Kal, so for 212H2O, nylon fishing line or thread, about 15 centimeters. A pencil or ruler, 2 jars, spoon, coffee filter or paper towels. The procedure: pour 1/2 cup of hot water into a jar. Add a little bit of alum to the water and stir it in. Try to do this before the water cools down too much. As you'll recall, we can expect the alum to be more soluble at higher temperatures. We want to create a saturated solution of alum, but we also want to make sure that all of it dissolves. Continue adding alum until it will not dissolve anymore. And then you can add a little bit more hot water to get the last bit of alum to dissolve. Cover the jar with a coffee filter or paper towel and let it sit overnight. The next day, pour the liquid into a second jar. There should be small crystals left in the bottom of the first jar. The process of pouring the liquid off of the top of the solid crystals is known as decanting. The crystals left behind will serve as the seed crystals to grow a larger crystal of alum. Pick out the largest crystal, or one with a nice shape that you like. Tie the fishing line or thread around the crystal, and tie the other end of the line to a pencil, ruler, or other long flat object. Adjust the length of the string such that you can use the pencil or ruler to dangle your crystal from the top of the second jar, the one that now contains the liquid, into the liquid without it touching the bottom. Once your crystal is hanging into the solution, all you have to do is sit back and wait for it to grow. This might take several days. If you notice small crystals growing on the sides or bottom of the jar, it would be a good idea to transfer the solution and your single growing crystal into another jar to prevent the alum in solution from crystallizing into several different crystals. This will ensure that you get a nice big crystal. You can feel free to transfer jars as many times as necessary to continue growing your large crystal. History of Chemistry Timeline Year Event 1859 to 1860 The early foundations of spectroscopy are established by Gustav Kirchhoff and Robert Bunsen. 1864 The Law of Octaves. An important step leading to development of the modern periodic table, is first proposed. 1865 The number of molecules in 1 mole of a substance is first determined. 1869 Mendeleev publishes the first version of the modern periodic table, containing 66 elements, and leaving space for yet to be discovered elements. 1869 DNA is first discovered. 1874 The second law of thermodynamics is proposed by Lord Kelvin. 1874 Electric current is proposed to be caused by the motion of electrons. 1876 The concept of free energy is introduced, by Josiah Willard Gibbs to explain chemical equilibria. 1877 Ludwig Boltzmann provides a definition of entropy, along with statistical derivations of several other physical concepts. 1884 Le Chatelier's principle is first introduced, explaining changes in chemical equilibria upon the introduction of changes in a chemical system. 1887 The photoelectric effect is first discovered. 1888 Radio waves are discovered by Heinrich Hertz. 1893 Alfred Werner establishes that some cobalt complexes involve a central cobalt atom bonded to an octahedral arrangement of 6 ligands, laying the groundwork for the field of coordination chemistry. 1894 Noble gases are first discovered. 1895 X-ray radiation is discovered. 1897 The electron is discovered. 1900 Planck's constant is first introduced by Max Planck. 1900 Ernest Rutherford establishes that radioactivity is caused by the decay of atoms. 1901 The Nobel Prizes are awarded for the first time.
What makes my cooking pans non-stick?
Heat coating that is placed on cookware is usually polytetrafluoroethylene. PTFE, marketed as Teflon, R, by DuPont, R. The strength of the CF bond, and its reluctance to interact with just about anything else, makes Teflon, R, very heat resistant and slippery stuff. Aside from coating cookware, it's used to make gears and bearings. And it's a key component of Gore-Tex, the material your waterproof jacket is made of.
What is a gel?
Gels are solid materials that have flexible properties. but do not actually flow in the same way that liquids do. They are made from a cross-linked bonding network of atoms, which actually contains a majority of liquid-like molecules interspersed by weight, but it still behaves as a solid. The cross-linked network within the gel gives it its solid-like properties, while the fluid component gives the gel its stickiness.
What is resonance?
A way of describing the delocalization of electron density in a molecule.
What is a compound?
A substance composed of more than one element.
What is a wave number?
Inverse of wavelength, typically reported in units of m1 or cm1.
Is lactobacillus harmful?
Lactobacillus is used in the production of lots of foods, actually cheese and yogurt. Sourdough bread, pickled vegetables, and wine and beer. There are helpful strains of lactobacillus living in your digestive tract too. So, to answer the question, lactobacillus is not necessarily bad for you in appropriate quantities.
What is mass?
The resistance of an object to acceleration, commonly used interchangeably with weight. Though the latter depends on gravity while the former does not.
What is saran, wrap?
Saran, wrap is a trade name, another held by the Dow Chemical Company, for polyvinylidene chloride. If two of the hydrogen atoms on every other carbon in polyethylene are replaced by chlorine atoms. Note yet again that this is not how this material is actually made. You get PVDC, or polyvinylidene chloride. It was discovered by accident in 1933 by Ralph Wiley, who was having trouble washing this strange material out of the bottom of a piece of glassware. The actual polymer they were trying to make was perchloroethylene, where every hydrogen is replaced by a chlorine atom. It was just before World War II that a breakthrough was made that allowed the scientists to make film from this new material. It was quickly adopted by the Army to wrap equipment being transported by sea in order to prevent corrosion from salt water and other applications to keep soldiers dry in jungle environments. After World War II, Dow found a new use for the material and introduced A PVDC film product for wrapping food called saran, wrap. The clingy food wrap you buy today is not PVDC, however. This material was phased out due to environmental and health concerns of those chlorine atoms. And low-density polyethylene took its place. Okay, but why was PVDC ever called saran, wrap? Many industrial trade names have no interesting story behind the creation. Saran, wrap is an exception. You might think that Ralph Wiley was responsible for naming this material. Having discovered it? Nope. Ralph Wiley's boss, John Riley, named the material after his wife and daughter Sarah and Ann.
What is a nucleoside?
A biochemical molecule consisting of a nucleobase and a sugar molecule.
How is coffee decaffeinated?
Consider the chemistry required to decaffeinate coffee. Most techniques use an extraction process to remove the caffeine from the green coffee beans before they are roasted. One method starts by steaming the green beans and then rinsing them with an organic solvent, usually dichloromethane, to pull the caffeine molecules out of the beans. The other method uses supercritical carbon dioxide to extract caffeine. The latter obviously avoids the use of toxic solvents, but is energy intensive. With all extraction techniques, it is challenging to only remove the caffeine and not the flavor compounds that we want to taste in our coffee.